Let's work on a practice problem. A construction company could enter a contract to build a mountain road. The following table shows the probability distribution for their potential profit if they enter or sign the contract. So we have this probability distribution. The first column shows the profit, the potential or possible profit that they will make. And in the second column, it shows the corresponding probability. For example, the company could make $30,000 in profit with a probability of 15% if they sign the contract. And they could make $50,000 in profit with the probability of 20%, and so on and so forth. So for this, with this information, we want to find and compute the expected profit that the company could make by entering and signing the contract. So please pause and work on this problem, try to solve it, and then come back to see the solution. All right, let's see the solution. So first of all, the random variable here, we're going to define it, x is the random variable, and we're going to define it as the profit that the company would make. So what be profit. So what we are looking for is the expected value of random variable x. And according to the formula that we have, which was equal to the summation of xi, the values that random variable would get, multiplied by its probability, its corresponding probability. So this means that we have to multiply 30,000 by its probability, which is 50%, 15%. So it would be 30,000 multiplied by 15% plus the next one. 50,000 multiplied by 20% plus the next one. 70% multiplied by 30, 70,000 multiplied by 30% plus the next one, which is 100,000 multiplied by 35%. So if we do this, we're going to get the solution. This is the solution. Let me get rid of these. So the expected profit for this company is $70,500 in profit. Let's do another practice problem. The number of no-shows, that means no show up, each day for dinner reservation at the Cottonwood Grill as a restaurant is a discrete random variable with the following probability distribution. So in the first column, we see the number of no-shows, and the second column shows the probability. For example, the restaurant gets 0 no-shows with the probability of 30%, 1 no-shows with the probability of 20%, and so on and so forth. So given this data and information, we want to find the standard deviation of the number of no-shows for this restaurant. So please pause, work on this problem, try to find the standard deviation, and then come back to see the solution. Right, so let's see the solution. So first of all, we need to define the random variable here. We're going to define x as the random variable, which is number of no-shows. So x is the number of no-shows. Then to find the standard deviation, we actually need to find the expected value. If you look at the formula here, the expected value, and in the standard deviation computation, we need to have the expected value, which is computed using this formula. So first we need to compute the expected value. The expected value is this random variable is just going to be the multiplication of the output of the random variable by its probability. So that means 0 multiplied by 30%, 1 multiplied by 20%, 2 multiplied by 20%, and so on and so forth. So after computing the expected value, we can just plug in into this formula to compute the standard deviation. So let's go ahead and do that. All right, let's see the solution. So the expected value is 1.65, and using that expected value into this formula, the expected value, and we can find the standard deviation. And the standard deviation is equal to 1.42. All right. Next practice problem. The following table contains the probability distribution for the number of daily traffic accidents in a small city. So we have the number of accidents, daily accidents in the first column, and in the second column we have the probability of that. So for example, the probability of getting no accident, zero accident is 10%, the probability of getting one accident is 20%, and the probability of getting two accidents is 45%, and so on and so forth. Given this data, we want to compute the mean and the standard deviation of the number of accidents per day. So please pause, work on this problem, try to compute the mean and the standard deviation, and then come back to see the solution. All right, so let's see the solution. So this is the formula for the expected value, and this is the formula for the standard deviation. We need to first find and compute the expected value. And the expected value is just as you see here, is the summation of multiplying each value that the random variable takes by its probability and then sum them all. So here it means multiplying 0 by 10% plus multiplying 1 by 20% plus multiplying 2 by 45%, and so on and so forth. After we do that, we're going to get mu, and we can use mu for the expected value in the second formula to compute the standard deviation. So let's go ahead and do that. If you do that, you're going to get the expected value would be 2. That means the expected value of the number of accidents, daily accident, is 2, and the standard deviation is 1.18. Next practice problem. The number of arrivals per minute at a bank located in the central business district of a large city was recorded over a period of 200 minutes with the following results. So here we have the arrivals in this first column, and we have the frequency in the second column. We want to compute the mean and the standard deviation of the number of arrivals per minute. So please pause, work on this problem, find the expected value mean and the standard deviation, and come back to see the solution. Right, let's see the solution. The first thing that we need to do, we need to actually have the probability distribution of this data. And right now we have the frequency. This means that for the frequency of having 0 arrivals was 14 out of 200 minutes. 14 intervals they didn't get any arrivals. 31 intervals they got 1 arrivals, and they got 2 arrivals in 47 period of time. And this means that actually if you add these frequencies up, you're going to get the 200, which is the 200 minutes period that we have had. So these are the frequency of these data. These are the values of x, and x, the random variable here, by the way, is the number of arrivals. So we need to find the probability of these arrivals instead of frequency. So we need to replace these with the probabilities. So let's find the probabilities first. How we can actually find the probability? For example, what is the probability of getting 0 arrivals knowing that its frequency is 14? So that's easy. That's just 14 divided by 200, right? Or for example, what is the probability of getting 7 arrivals? 7 arrivals, knowing that its frequency was 5. That's easy. 5 divided by 200. That's going to be its probability. Right. So let's first build that table and then move on with the solution. So this is the probability distribution of this random variable. The probability that they get 0 arrival is 7%. The probability that they get 1 arrival is 155,000, and so on and so forth. So now we can actually use these formulas to to compute the probability. The first one, mu is, this is the formula for mu, and this is formula for a standard deviation. So first we need to find the expected value, or mu, which is just summation of xi multiplied by pxi. So we have to, for example, multiply 0 by its probability, 7%, multiply 1 by its probability, which is 155, multiply 2 by its probability, which is 0.235, and then add them up, and then we get the mu. So if we do that, we're going to get the expected value, and that's 2.9. The expected value number of arrivals is 2.9. And if we plug it in, every value is in the sigma formula, we're going to get the standard deviation, and that's 1.77.